This is a problem worked through for problem 137 in lesson 4.4, simple collision calculations. Now, the formula for these problems looks very challenging. As you can see here, we have our elastic collision and our inelastic collision formulas. Now, it does look very confusing and very complicated. It's really not that bad. Basically, you have two objects, a first object, a second object, mass, and a speed, and then you have the same two objects mass and then a final speed for each of them. Now that's in an elastic collision where the objects will impact and then bounce off of each other. It actually gets a little bit simpler in an inelastic collision where the two objects collide and become a single object. So you have a total mass and a total velocity. So the first thing you need to do when you look at these problems is determine, do the objects stick together or not? So let's check out this problem. A 15-gram bullet is fired from a 5-kilogram rifle at a muzzle velocity of 600 meters per second. Calculate the recoil velocity of the rifle. Now, in that problem, there is nothing that says that the bullet and the rifle stick together after the collision. Okay, so what if we apply common logic? We know that bullets are fired out of guns. They don't stick to the gun. So we can assume this is going to be an elastic collision. So let's start with our laundry list. Now we have a bullet. It's going to have a mass, an initial velocity, and a final velocity. We also have a rifle. It's going to have a mass 1 and mass 2. It's going to have an initial velocity and a final velocity. So let's start with the mass. So the bullet is 15 grams. Now we can automatically write that in kilograms as 0.015 kilograms. It is fired from a 5-kilogram rifle, so 5-kilogram rifle, at a muzzle velocity of 600 meters per second. That means that the bullet is fired at 600 meters per second, but initially the bullet is going to be not moving, right? Because initially, if we think about the bullet firing out of the rifle, both the bullet and the rifle are not moving. Now, once it's fired, the bullet is shooting at 600 meters per second one direction, and the rifle is going to recoil and go the other direction. So the recoil velocity, the final velocity of the rifle, is our unknown. So now, if we start with our formula, M1 VI1 plus M2 VI2 equals M1 VF1 plus M2 VF2. Now we just plug in the numbers that we know. M1 V1, M2 V2 equals M1 VF, M2 VF. So we have 0.015 times 0 meters per second plus 5 kilograms times 0 meters per second equals 0.015 multiplied by 600 meters per second plus 5 kilograms times final velocity of the rifle. So we have 0 plus 0 equals 0.015 times 600 is 9. And then plus 5 VF2. So if we subtract the 9 over to the left, because the zeros, they just disappear, so minus 9 minus 9, we end up with negative 9 equals 5 VF2. We're going to divide this side by 5, divide this by 5, And we end up with a final recoil velocity of the rifle that is negative 1.8 meters per second. Now, when we think about this logically, this is the recoil velocity of the rifle. So it is going to be moving in the opposite direction as the bullet. So if the bullet was moving at a positive 600 meters per second, we know that the vector direction for the rifle is going to be in the opposite direction. That's why it's negative.